Hello everyone, this is Greg from ChemCore. In this video we're going to be going through the sigma and pi bonds worksheet. If you haven't had a chance to check this worksheet out, it should be in the description below, as well as the answer key. And if you haven't had a chance to watch the instructional video explaining sigma and pi bonds, should also be in the description below. Make sure to check those out. Well, the first question obviously is asking us to calculate how many sigma and pi bonds there are. Now notice that it doesn't say carbon-carbon, right? It just says in general, right? So like all sigma and pi bonds, which means that includes, carbon-oxygen bonds, an oxygen-hydrogen bond, even carbon-hydrogen bonds, nitrogen-hydrogen bonds. Any bond that contains a sigma or a s orbital will count as a sigma bond. And then any interaction of the p orbitals will count as a pi bond. And so what's important is that we should mark where our sigma bonds are. And so I'm going to draw like a little dash here to show that we kind of have these two hydrogens and this hydrogen branching off of here as well as off this oxygen. And I will also have two hydrogens coming off this carbon and one hydrogen coming off here, and that should cover all of them. And so let's do sigma bonds in a green. So we'll count our sigma bonds in green. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, that means we have 15 sigma bonds. Let me clean up this little mess we have here. I'm not gonna remark. I'm not gonna redraw those hydrogens because hydrogens are only capable of sigma bonds. They don't have a p orbital, and so we'll do pi bonds in blue. And so we're gonna look at all the double bonds and triple bonds. Clearly, we don't have any triple bonds, but we do have two double bonds, and so these two will count as our two pi bonds. And so we'll have two pi bonds, meaning that our answer should be E. There we go. The next problem is asking us about the molecule propyne. Now, I know you guys don't know how to name stuff, and that's okay, because they gave you the formula. And I can't do this in my head. I need to draw this out. I don't know about you guys. And so what I'm going to do is, well, obviously, let's try drawing it out. So we'll have C, C, C. Clearly, we'll have an H coming off here, an H coming off here, an H coming off here, H coming off here. And now what's maybe more required from you is knowing that ine means alkyne. Okay, meaning that we should have a triple bond somewhere. And you don't actually have to know that. You'd be able to realize that, hey, the way this structure is drawn, it wouldn't make sense with a number of hydrogens because these carbons will not have 4 bonds. And so we need to have a triple bond over here. There's no other way that the structure works. And so now we can calculate how many sigma and pi bonds. Again, we'll do sigma in green. So this bond, this bond, this bond, this, one of these bonds, and one of these bonds. And I count 1, 2, 3, 4, 5, 6 sigma bonds. And now the only pi bonds that I'll see are the 2 extra bonds that we have on that triple bond. And so I only count 2 pi bonds. Therefore, our answer should be C. Remember that a single bond has one sigma bond, a double bond has 1 sigma bond and 1 pi bond, and a triple bond has 1 sigma bond and 2 pi bonds. That's really important to remember. It's really going to help you break down these questions easier. The next question is asking us to find out how many sigma 1s sp3 bonds there are in ethane. Now, I'll explain what this means. I know this must seem confusing. It's really not. Let's first of all, ethane, I can't do this visually, and so let's draw out a little structure for this. So we'll have something like this. All right, ethane. I know you guys don't know what ethane is. We did not do nomenclature yet, but they gave you the formula, so they don't really expect you to know the name. What does 1s and sp3 mean? Well, 1s refers to the type of orbital that one of the atoms has, and it's kind of your job to figure that out. Well, carbon will not have a bonding 1s orbital because all these carbons are going to be hybridized. And so this 1s orbital belongs to hydrogen. Okay, there's no other way that it can belong to anything else. But sp3, or the way it's drawn, I know this is, the 3, it looks a little weird, must belong to carbon. Because we only have hydrogen and carbon here, which means that the only thing that could be hybridized to sp3 is carbon. Basically, what they're asking us is how many hydrogen-carbon bonds are there? And so I see, well, 6 of them. 1, 2, 3, 4, 5, 6. And so our answer should be 6. Realize that it's not really asking you anything else. If you counted this carbon-carbon bond, you'd be wrong. It's only asking for the carbon-hydrogen bonds. The next question is asking us to identify the atomic orbitals in the carbon-carbon sigma bonds in ethine. And so what we're going to do, I always draw out a structure. Doesn't matter if I can kind of know it right away. So ethine, I know you guys, again, don't know nomenclature, but they gave you the formula. And so what they're asking us is, okay, this sigma bond, one of these bonds, so one of the bonds of the triple bond, what are the atomic orbitals that account for this bond? Well, what's interesting is that you don't really have to understand the atomic orbitals. I mean, I'd like you to, but you can get away without it. You can just understand the hybridization of each of these carbons. Now, knowing that it's a triple bond, this should tell you right away that this is sp hybridized. If you're unfamiliar with hybridization, check out my previous videos. We have another video on hybridization as well as the atomic orbitals and explaining all of this. And so realize that we're just asking, hey, this sigma bond is made by the interaction between an sp hybridized carbon and an sp hybridized carbon. And so our answer is 2sp, 2sp. Now in this problem, they're kind of asking us a similar question, well, the same molecule, ethine. So let's redraw ethine. Okay. But now they're not asking us about the carbon-carbon sigma bond. They're asking us about the carbon-hydrogen sigma bond. So one of these. And again, you just have to realize what is the hybridization or which atomic orbitals are interacting to create this bond. This carbon, well, is sp hybridized because of that triple bond. And this hydrogen only has one electron to give, which is in the 1s orbital. Remember your electron configurations. And so our answer should be 2sp, 1s. So the answer is E. The next question is asking us how many total sigma bonds are present in the following compound. Now this is a benzene derivative. It's actually toluene. And so we have to realize they didn't tell us carbon-carbon. Again, they're asking us for everything. All of the sigma bonds. And so to do this, we're really going to have to, first, let's make sure that we have all our hydrogens drawn. And so on each of these carbons, we're also going to have an additional hydrogen. And on this ending carbon, we're going to have 3 additional hydrogens stemming off. And so what we're going to do is we're going to count all of them. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so our answer should be D, 15. Remember, a double bond consists of 1 sigma bond and 1 pi bond. Hydrogens cannot go into the p orbital. They don't have electrons in the p orbital, so they will not be able to form pi bonds. And so those carbon-hydrogen bonds are all sigma bonds. It would be a different story if they asked us how many carbon-carbon sigma bonds. But since they're not specifying, we have to, count it for every single bond in the molecule. Now, the next question has the same molecule, but it's asking us kind of a different question. It's asking us how many electrons contribute to pi bonds in the following compound. Well, the first job we're probably going to do, I think, is, let's count how many pi bonds we have. And so I see only 3 of them. 1/2 of all the double bonds. And so I see 3 pi bonds. So 3 pi bonds. And this is not anything out of the box. This is not an unordinary question. You should know by now, you should be very familiar with by now, that a covalent bond is composed of 2 electrons, 2 shared electrons. And pi bonds are still covalent bonds. They're just a different, just a little quirk. And so since we have 3 pi bonds, we should have a shared 6 electrons between these 3 pi bonds. And so our answer is C. In the next couple problems, we have to determine the number of carbon-carbon sigma bonds and pi bonds And now for you guys, I made this a little bit simpler than the previous problems. I could have made you calculate all of the sigma bonds and pi bonds, but I decided to go easy. And so we're only going to focus on the carbon-carbon sigma bonds and carbon-carbon pi bonds. And now what I like to do is, well, let's kind of note where our carbons are. So maybe I'll just note it here. It makes it a little easier to see. We're going to do this for the first problem. You don't really, if you feel fine without it, you don't have to. And now every single bond is going to be a sigma bond. And so 1, 2, 3, 4. So I count 4 sigma bonds. And now pi bonds are only created by the double bonds between the carbons. And so the only double bond I see is this one. And so we'll only have one pi bond. Let's do the same thing for the next problem. Again, you see all these oxygens here. It makes it confusing what bonds are between carbon and what bonds are between oxygen. It makes it easy to make a mistake. And so I'm just going to like mark with a dot where my carbons are. Makes it a little bit clearer because of, you have a lot going on in this molecule, and that's going to be similar to everything else. And so let's count how many sigma bonds we have first. I see 1, 2, 3, 4, 5. Remember, we're only counting the bonds between carbons. And so I count only 5 sigma bonds. And now to count the pi bonds, we're going to look at all our double and triple bonds. I don't see any double bonds. I do see a triple bond. And a triple bond is consisted of 2 pi bonds. And so we'll have 2 pi bonds here. Let's use the same strategy for the next problem. We'll have carbons here, all over here. Let's mark them down. All right. And let's calculate how many sigma bonds. I see 1, 2, 3, 4, 5, 6, 7. So I count 7 sigma bonds. And pi bonds, we only have to look at the double and triple bonds, which I only see 3 double bonds, like earlier in the worksheet. And so I should only have 3 pi bonds. Let's do the same strategy for the next problem. Now you understand why I like to mark my carbons, to makes it a little easier, because you have a lot of other elements hanging around in this molecule, and it's going to make it a little bit more confusing. And so this carbon does not have any interactions with any other carbon. And so we can kind of erase this, just not worry about this. And between all these other carbons, we only have 6 single bonds and no double or triple bonds, meaning that we have 6 sigma bonds and 0 pi bonds. Same strategy for the next problem. Going to mark down all our carbons. And again, I only see single bonds between our carbons, no pi bonds. And so I count 1, 2, 3, 4, 5 sigma bonds and 0 pi bonds. Let's mark all our carbons. So we kind of have 2 rings stacked together. It's interesting because later in Orgo 2, you'll learn how to create these molecules. It's one of my favorite reactions, and I can't wait to teach it to you guys. But to calculate the sigma bonds, let's count all our sigma singles. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I count 9 sigma bonds. And pi bonds should be 1, 2, 3, 4, 5 pi bonds. 5 pi bonds. That concludes all our problems in our worksheet. Remember, try this worksheet again. If you're really having trouble with these concepts, check out the sigma and pi bonds instructional video. We also use some concepts from the atomic orbitals and hybridization video, so check those 2 out. And you can focus on the hybridization with another worksheet in the last video. And I will see you in the next one.